Well, good afternoon, everyone. Thank you for attending today's webinar, Simplify Your Broadband Data Processing with Automation. My name is Amy, and I'm the Operations Manager here at National States Geographic Information Council. If you're unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to know more about us, please visit our website, www.nisjig.org. Some reminders for our call today. All attendees have been muted on entrance, and there will be time at the end of the presentation for Q&A. So please place your questions into the chat box, and they will be read aloud at the end. Also, a recorded version of this webinar will be made available afterwards, so please be on the lookout for that email with that information. And with that, I will now turn it over to the presenters from One Spatial. Thank you for joining us.
Thank you, Amy, and thank you for NSGIC for letting us host this this webinar today. I am here to just introduce Melissa. Amy, is everything working? Because it seems like my screen is frozen, but just making sure that things are working.
Kevin, it looks like I can hear you perfectly, but I cannot see your face.
Okay. Well, what I'll do, my machine, it looks like it's about to crash. So I'm going to go ahead and quickly pass it over to Melissa. Melissa is going to present on this topic. This is kind of a continuation from our presentation that we gave last at the NSGIC mid-year. Sheila gave it in my stead, and today I'm filling in for Sheila in her stead. So anyway, I'm going to go ahead and just pass it over to Melissa while I deal with my Zoom issues. So thank you.
Thanks, Kevin. And for me too, to kind of avoid any Zoom issues or whatnot, I won't be sharing my camera, unfortunately, but I promise I'm here and presenting to you live. So today we'll be presenting on our ways to use automation to simplify the process of working with your broadband data challenges of the Broadband Serviceable Location Fabric, or your BSL. Ooh, it's not going. There it is. All right. So my goal for you, for those of you who are tuned into this webinar, is to lift any of the anxiety that you might have towards dealing with your broadband data. And so before I even bring broadband data into the picture, what I would like to talk about is data in general. So, in whatever shape or form it takes, how is it that working with data can feel both exciting and intimidating at the same time? Where and how do we obtain our data? What steps can we take to objectively put trust in our data? And more importantly, how do we maintain that trust in our data once we get there? So answering these questions is really crucial because they do have the potential to dictate your data process moving forward. It's like laying down that first domino piece. If your data's origin and quality are unknown, you should feel some uneasiness about leveraging that for other uses. That foundational quality sets a precedence for how all the other dominoes you line up behind it are affected. And while the accuracy of your jurisdictional boundaries, your address points, your road center lines, parcels, be those GIS parcels or CAMA or computer-assisted mass appraisal records, and building footprints, these are not necessarily a prerequisite to your broadband data, but it does play a role in how you're able to participate in the integrity of the national broadband map. And with that, I want to provide a brief overview of the National Broadband Map, which is essentially another national address data set that can only be used for broadband purposes. This new map has been upgraded from a census block level of accuracy to a building structure level of accuracy. So if you visit that map right now at broadbandmap.fcc.gov, one of the ways that you can interact with it is by submitting what they refer to as challenges. So the FCC site actually has a treasure trove of informational FAQs about these challenges. It does include details that would, information that would actually warrant a challenge. But before we get deeper into that, I would like to provide a little more context on the foundations of broadband data collection. So let's talk about the underlying data set for the FCC's fixed availability maps as part of the broadband data collection, and that would be the Broadband Serviceable Location, or BSL Fabric. The BSL Fabric utilized 2 machine learning models, so between which they extracted structures from imagery and they identified which structures within a parcel would make the best candidate for BSL if it's not already been established as a BSL. And then they overlay that data with commercial parcel and address information to be able to provide more context into it to further establish that a location should have a BSL or not. Information such as the postal address, designation or the land use, information on potential building improvement values, number of units in an address, etc. So given how the BSL Fabric was created, what considerations should we give its underlying data foundations? The imagery used to capture those building footprints might be dated. So one of the questions is the data actually current enough to capture all the new construction across the country? And speaking of construction, sometimes areas have not actually been built out, but already they have been pre-parceled and assigned individual addresses. Also, if a location has multiple units with each one having its own address, well, it's not necessarily the case that these individual addresses are represented in the postal information. So it's really from these types of considerations where we build data quality standards from. It's where we can build data validation rules from. Because as we've determined, the quality of your data foundation can reverberate like a domino through everything else that's created with it. So I do want to revisit this slide, because these data sets are actually foundational to support more than just broadband challenges. They are relevant in Next-Gen 911, in underground utility assets, emergency response, COVID response, etc. And hopefully, if there's one thing you know about One Spatial, is that we are all about data automation. We have a number of customers that use our One Integrate rules engine to automate the validation of these data sets, as well as an automated data integration across various databases and systems. Because as we all know, not all of these data sets might be sitting in the same database repository or system. However, the key to smooth automation is that there are actually standards in place. So if we want our foundational data sets to be able to meet and maintain those high quality standards, well, we must establish that they meet business requirements. And so before we get even deeper into the topic of broadband, let's go over an example of a business requirement that involves 3 of these foundational data sets. So let's say that an organization has their address points, their building footprints, and their parcel polygons. And the business requirement, which we'll later on find out to be actually relevant in broadband, is that the address point must be contained within a building footprint, within a parcel with the same address information. So in this scenario, that address point at the bottom does not meet that business requirement. So what can be done to catch and correct it so that it does meet the business requirement? Well, how about configuring it with a configuring it within a rules engine? So this is how the business requirement looks like when configured within the One Integrate rules engine. Now, some of you on the call might be familiar already with One Integrate prior to this version and thinking, why does it look different? Well, what you're actually looking at is from the brand new user interface for version 4.0 of One Integrate, which was officially released earlier last week. And one of my favorite new features on this is that you can switch between light and dark mode. So you're seeing it right now in dark mode. What we have done is we modernized One Integrate to give users a more intuitive experience. We wanted it to be more responsive to familiar mouse and keystrokes that are similar to Microsoft Teams, to Slack, to email clients, etc. Specifically, what we're looking at here is a screenshot of the rule authoring interface. So it is still very much a no-code rules engine, but we just improved this to display a more visual node tree. And again, just make it a more intuitive dynamic experience altogether. I'll actually be taking you to a 4.0 environment later on as part of this presentation. So that's a little something to look forward to. So using your foundational data sets as context in the interface, a user can configure the business requirement to say, here's the feature class that must be validated, which in this case would be the address point. And between parcels and the building footprints, here are the different spatial and attribute relationships that they are expected to have, again, according to the business requirement. So at the top line here, and I don't know if you're seeing my mouse cursor, at the first top line here, you're seeing that the rule checks that an address point is contained within a building footprint. And then it goes on to check that an address point is contained within a parcel as well and shares the same address information. By configuring the business requirement as a rule, we have effectively automated the validation of that address point. And now that the system can automatically identify where the business rule is not met, we can go a step further and actually configure a rule to automate the correction of that address point. Sorry, I went one step ahead. So an organization can do that by leveraging the available information from the building footprint and parcels and infer a rules-based relocation spot for that address point. Here, the configured rule could say if the address information matches the address point and the parcel that contains it, assume that the largest footprint within that parcel is the most likely location for that address point. The system could also be used to configure a rule that says within a certain set of confidence tests, automatically apply the proposed new location for the address point so that when it is run against the rule at the beginning, it ends up meeting the business requirement. So bringing this into the context of broadband, the value of validations like this could evolve to automating bulk challenges. So for example, one of the business requirements for BSLs are that they are associated to address points within the building footprint. So if an organization has gone through the effort to validate its address point data, just like we covered in the previous 4 slides, then they can leverage it as a clean foundational data set for a wider use. Example, broadband. And then from identifying data that does not meet the business requirements to correcting the data so that it actually does meet the requirements, that's the type of process that promotes the implementation of an SDI or spatial data infrastructure. So switching gears here for a bit, and I do want to talk about SDIs. And I feel like this image right here successfully illustrates it, and particularly as it relates to data foundations. So when we talk about SDIs, what we're really referring to is a type of data infrastructure that protects, preserves, moves, and serves spatial data. SDIs are essentially routes that enable value to be created out of data. From these routes, we establish a foundation of where the data is collected, promote the use and maintenance of authoritative data, power spatial readiness, and produce quality data. And when we produce quality data, we are confident that it will be trusted and reliable for others as well. If you're interested to learn more about our approach to tackling SDIs, this content here and more can be found in our digital publication called The Little Book of Spatial Data Infrastructures. You can download it along with all our other little books, as we like to call them, from our website at onespatial.com. So with that in mind, the process of finding address points outside of buildings within parcel polygons and fixing them, it summarizes the steps that can establish a framework for building out SDI tree routes. On a larger scale and as a rather repeatable process, the data benefits from an automated approach to standardize the data coming in, validate them against rules based on business requirements, detect any anomalies with how it interacts with other data sets, and within a set of parameters, apply rules that will fix or clean up the data. To ensure the process maintains high quality data that is both trusted and reliable, it is again validated. It is validated again. So to show you just how repeatable we have made this SDI, here it is in the context of our public safety and G911 solutions data supply chain, with the data coming in from our PSAPs, counties, COGS, etc., and the validation rules that ensure the data conforms to next generation 911 standards. In this use case, our SDI supports parcel data supply chain, even as the data sources are not necessarily all spatial and therefore not stored and maintained in the same system. The validation rules are then configured to take into account the different purposes for which the data sources have been created and maintained. So for example, applying fuzzy matching between address information that's stored in GIS parcel polygons versus your parcel records that are sitting in a flat CAMA system. So I will actually demonstrate this to you using our One Data Gateway portal. But first, let's take a look at the data that we're about to check. So right now, the GIS parcel polygons, we're going to take a look at what's actually in the data that's actually in here. We have our parcel ID, address information, information on the owner, the land value, etc. On the CAMA parcel record side, we have similar information. You have at least your parcel ID, your owner name, address information, assess the value, land value, etc., etc. So definitely there are attributes in there that we can go ahead and cross-check and see how well synced up they are. So let's say that the state has set up this 180 gateway environment for me to use. And as a local government maintaining my own GIS parcels, for example, I want to make sure that the information stored in my parcel polygon attributes actually match what the state's compiled camera records have. So I'm going to go ahead and sign in here. Click on my parcel polygon versus camera validation tile and go ahead and make a new submission. So for this example, the state has already set up for me to have access to the CAMA system's parcel records. So all I need to do here is drag and drop my parcel data. Oop. Sorry about that. Here we go. So the schema of my parcel submission is currently being mapped with what the rules have actually been written against. And we're seeing here that it perfectly matched the schema that it was expecting, that the rules have been written to write against. So if the case was that some of these attributes did not match over, I have the option of matching these attributes myself using a drop-down menu. And really only have to make this effort once, because at the top here, I can go ahead and hit manage schema mappings and save that for next time, kind of like a set and forget type of thing. So at the bottom here, I'm just going to go ahead and say, go ahead and continue my parcels and run this validation. So we're seeing here that the first two rules are very basic. They check that a camera record has a parcel ID, and they're checking that parcel polygon has a parcel ID. They're checking that all the data, be it in the GIS side or the CAMA side, make sure that those unique parcel IDs are actually populated in the first place. And we're seeing here, as we've seen these instant results come in, that not all of the CAMA records have parcel IDs. On the parcel polygon side, however, we are seeing 100% of that meets that requirement. Sorry, just had to clear my throat there for a second. And then it's checking for the completeness between the systems. Are all of our camera records represented on the GIS side? Are all our parcel GIS side represented on the CAMA side? Are all our CAMA parcel records are represented on the GIS parcel polygon side? So we're seeing here that some of the parcel polygons that I submitted actually do not have their parcel IDs represented on the CAMA side. So you're seeing a 99.61% conformance rate for that one. And then we have a couple of examples here where we apply what I mentioned earlier, which is the fuzzy matching. So in here, we're saying that if the polygon and the camera records are representing the same parcel, as in they have the same parcel ID, we are expecting that their address information must be a perfect match. So for this rule, we're seeing that we have 96.82 of our records do meet that rule. However, if the rule instead says that if the rule instead says that the address information between the two must have a string match confidence of at least 95 instead of a perfect match, then that kind of gives us a little bit of room for minor spelling mistakes, etc. We're seeing that we're seeing that conformance rate hit 100%. We also do the same for the owner information, just as another example. And while we're not seeing 100% improvement on that, we were still able to bump that conformance rate up a bit. And then as a last rule here, checking that the property land value also matches between the two. So one of the things that I want to point out here is that while these results are instantly useful to me as a data contributor, what would really help me meet these requirements is if I actually had an output file that can pinpoint exactly where my data issues are. So on the next page, that brings us where we can export a copy of these results. All right, so I'm going to go ahead and move over to Pro, to my GS application of choice, and go ahead and take a look at what some of these non-conformances look like or data issues look like. So right now, I have it selected. We have a non-conformance here that's been reported. It says that it failed our rule 4A, which says check that the owner for information in the parcel polygons matches the camera record. The markup has already reported out that on the camera side, the owner of this parcel is James M. Kelly. On the GIS parcel side is just James Kelly. It assigned that as a confidence string match of 96.9. So what we're saying here is that it does meet, or within a 95% passing threshold, this would meet that matching conformance. So what you're seeing here is that when I selected it, it's only non-conformant to the first version of the rule, which is 4A. But once we gave it an allowance of 95% and up for it to match, we're not seeing that being flagged anymore. So just as an example of how that fuzzy matching can be applied. I have another example here where we have an address information in the parcel polygon. So right here, it says 9027 Barber Street on the CAMA side. On the parcel address, it's 9027 Barber Street. It gave us a confidence of 97.4. We're not seeing that anymore on the 95% passing threshold. Let's take a look at another example here that I have, one where we didn't see a 95% and up string match. So in here, the CAMA owner is ABC LLC. On the parcel side, it is John Smith. And that gave us a very low confidence of 41. And that's why even with applying the fuzzy matching, it's just still being marked up as an issue in the data. So putting this back in the context of broadband, we have to be able to have a solid foundational data set like parcels, because they could hold the key to identifying BSL challenges. And if you know your local parcels meet your business requirements, then you can actually leverage that quality to validate the BSLs that the FCC has on your state or your locality. It's that address, the land use, the land value, etc. All of that information could have a bearing in locating or validating your BSLs. So one of the documents that are available on FCC's website is a Fabric Challenge Category Code Overview PDF, and it lists the 7 types of BSL challenges. So, so we're seeing here that you can report out that a BSL or a broadband serviceable location is actually missing. We can report out an incorrect address, incorrect location unit count, incorrect building type code. You can report that a BSL is not within a correct building footprint. You can report that a location is not a BSL. And also you can report out that an address needs to be added. An address needs to be added to an existing BSL. So here's an example of a broadband service location. Notice how they are at the building structure level. These are not there are no points where there are sheds or smaller footprints, and there's only one green BSL per property or per parcel. Here's an example of where we're finding a non-valid valid challenge data. What we're seeing here is that the organization has a list, has addresses, and they have been geocoded to the road center line. So unfortunately, the FCC really has no way of knowing where they are missing BSLs. And from the look of all these green BSL dots, it really doesn't appear that they are missing any potential BSLs anyway. But for a challenge to be valid, those address points must be spatially related to the BSLs within a building footprint and within a parcel. So what I want to tackle now here is how we can turn some of these BSL challenges into configured rules, just like we did with the address points and the building footprints and the parcels. So in this example that you're seeing here, we're seeing a category code of 5, where it is a challenge type of BSL location that needs to be changed. So we have two images right here at the bottom of our screen. We're seeing address points in orange and our BSLs in blue. On the left-hand side, we are seeing that they are sitting in 2 separate building footprints. How do we know which one is supposed to be the actual, the correct building footprint to be in? And on the right, we're seeing that an address point is sitting in a building footprint, but the BSL is not. So how can we configure rules to be able to meet the business requirement that an address point in a BSL must be sitting within the same building footprint? So I am now going to jump into One Integrate 4.0 and give you a quick tour of, or not really a tour, but give you a quick preview of what this actually looks like as a interactively. So in here, I have a rule that's been set up to identify any missing BSLs. So hopefully, well, I'm going to go ahead and zoom in here. So we are checking that our address points meet our business requirements. So in here, we're saying that an address point is contained within a building footprint, but there are no no BSLs within 50 meters of the address point that share the same information. If that's the case, then go ahead and report a challenge category code of 1. I'm going to go switch into another rule here where we're checking the BSL unit count. And again, we're checking our address points here to say, if it's the case that an address point is within 50 meters of a BSL, and they also have the same address information, then go ahead and run this and say, if the address point is within a parcel, but that parcel's information on the unit count does not match the BSLs, then go ahead and report out a challenge category code of 3. Oh, I'm sorry. Let's actually take a look at what these could look like, or what these would look like as a result. So I ran more than just those 2 rules in here. I reported out category 1, 2, and 5 as an example. And what we're seeing here is we are first starting out with our parcel polygons. I overlaid that with the building footprints. I have we have our BSL in blue and our address points in orange. I'm going to bring up my markups too, because as we're seeing here, this BSL has already been flagged as not even having an associated address point. But I want to focus on some of our categories here one by one. So in here, we have identified an address point that does not have an associated BSL. And you're seeing that within this parcel, even though that is within the footprint, you're not seeing that blue triangle within that same parcel. In this scenario, it is reporting a possible category 2 challenge because the BSL's address information does not match the associated address point. So let's go ahead and check that. And we're seeing that it's 714 East Keel Avenue versus 714 West Keel Avenue. And what we're seeing here is we also calculated a string confidence score, and it has a confidence match of 90%. So that is something that we probably want to look at. Another example of a challenge here. And what I really want to do here is kind of get a little deeper into why this issue might arise. So taking a look at where our building footprints are. One of them does look like a bigger shed, but on the right is being reported as where that address point is actually sitting in. Looking at the BSL, it is definitely outside of the building footprint. And one of the things that, again, that we need to be able to observe with our BSLs is that they fit the requirement of being within a building footprint and an associated address point. believe I have another example here where we do have an address point and a BSL within the same parcel, but they are sitting in two different building footprints. So flagging that as a possible category 5 where a BSL is not within correct building footprint. And so we can absolutely configure all these rules and automate how we're creating these bulk challenges. Again, running through all these different category codes of 1 through 7 and being able to automate where we find these issues where the business rules are not met, and be able to automate a way to also fix them so that they do meet the business requirements. So the BSL challenge is really basically taking your existing address points, your parcel data, your building footprints, and being able to look for missing and added locations that is within one data set and not the other. It's really just a geospatial data conflation process. And we at One Spatial specialize in data conflation. We've done it for national level data sets, such as the US Census Tiger Line, NPMRDS, which is a national traffic conflation process, crash data conflation, and so forth. More relevant use cases are in the address and POI matching conflation work that we have done, where we have matched 2 district address data sets, identifying them between or using spatial proximity and attribution, trying to find out where they are likely matches and score them on spatial on confidence. We've also done conflation projects for commercial vendors with points of interest data sets. For example, we performed a conflation exercise in 28 million points of interest data sets between multiple data sets and able to identify the best in breed of POI data sets. So it's the entire process. For that example, the entire process finished within 1 business day. So the key really to all of these different projects that we've done is that they have been automated, and it's repeatable, it's objective, it provides traceable results and instant metrics, and overall, that's what makes for a healthy, holistic spatial data infrastructure. All of these benefits feed into tackling challenges in data foundations. And so the message is to water your SDI tree by working from the foundational data sets going up so that it protects, preserves, moves, and serves your data. You want to be able to produce quality data and be able to promote data on interoperability. And with that, we are ready to take some questions. Hopefully we still have time.
Thank you, Melissa. Yes, absolutely. We definitely have enough time for questions. So if anyone has any questions, you're more than welcome to place them in the chat box and I will read them aloud. I'll give folks a minute.
And while everyone's doing that, just to reiterate a couple of points that Melissa brought up, Melissa really went into some deep dives into understanding your spatial data foundations, your spatial data infrastructures. This is important, obviously, beyond just broadband serviceable locations. These things keep coming up. Like Melissa mentioned this before, like COVID response, BSL, Next Gen 911, all of these initiatives all require a strong data foundation. So whether you're addressing your spatial data infrastructures for broadband or whatnot, it is important to invest in that into that spatial data infrastructure. And what better way to do it is through automation. And also when it comes to broadband, is once you have that strong foundation, you can then start to validate the broadband serviceable locations against those that strong spatial data infrastructures. So I don't know if we're getting any questions, Amy.
Not yet. I have not seen anyone post a question, but everyone feel free to post one if you'd like, and we can take some time to answer that. I'll give folks a minute.
with that, Amy, I guess we're not going to get any questions.
Well,
Well,
I do want to thank Melissa and Kevin. Thank you so much for both coming on and presenting today. This was a very great and informative presentation. And once again, a reminder to the audience, this is recorded and will be sent out after the webinar. So please feel free to look out for that. Any last words from the presenters?
No, that's-
Please don't be shy to contact us if you have any questions or are interested in more information. We're absolutely here to take more questions outside of the webinar time. Always.
Absolutely. I mean, I've been working with the One Spatial team for a while, or a couple of years now, and they're the best. They always are round to help and answer any questions. So thank you again, Melissa and Kevin, for coming on today. We really appreciate it. And thank you to the audience for joining us today. We all hope you have a great afternoon.
Thank you.
Thank you.